of Physics 253, Week 8, problem number 28.7. In this problem, we are asked to find the resistance of a hairdryer as well as the current when the hairdryer is used. So I've gone ahead and drawn a little diagram here of a hairdryer. I don't think it's the most helpful diagram, but I am kind of just trying to say that there's some kind of uh, power here as well as the resistor. So this problem, it really depends on an equation that we're given in 28.3 of the book, Energy and Power. This equation here, 28.12, is pretty much all the different relationships between power of a resistor as well as current and the potential difference of resistor, um, as well as resistance are here. So I really like these equations. It's laid out really nice in the book. Just in that this is kind of just all different variants um, of Ohm's law and the power, which is kind of cool. Um, so just go ahead and getting into the problem. Um, we have that our power of the hair dryer is 1300 watts as well as 120 volts. So since we're dealing with watts and volts and we're looking for resistance, we can use this relationship here and here, and then we can just go ahead and rearrange for R to solve for resistance. And so what we're going to do is just plug in 120 volts into our, this is the potential difference of the resistor, and then our power is going to be below here, and our power is 1300. So I think we end up with like it's a different number. This is rounded for mastering physics, but it's 11.1 ohms. So for the next part of the problem, we're asking for current in the hair dryer. Again, this one's pretty straightforward. We're just going to be using this relationship again, except we're going to be using this right here, since we have potential difference of the resistor, as well as current and power. I suppose that we could use something involving R, but this one just made a little bit more sense to me. So um, getting into the problem here, we just have to rearrange for I, or current, and just plugging in, we have our power divided by our voltage, as well as, or excuse me, as over our potential difference of the resistor, and we end up with 10.8 amps. And again, this is rounded for mastering physics. Yeah, so this problem is pretty straightforward. I would say just knowing when it comes to problems like this, it's just kind of knowing the relationship between power and Ohm's law. You just kind of have to make sure you know what variables you have and what you need. But I would say other than that, it's pretty straightforward. Thank you very much for watching, and I hope you have a great rest of your week.